Consider an infinite ladder network shown in the figure having a voltage V applied between the points A and B. This applied value of the voltage is halved after each section. So what will be the value of what will be the ratio of R1 to R2? First of all, let me redraw this diagram. Before we redraw this diagram, understand that let this resistance over here, the equivalent resistance, be equal to R. So the resistance on the right hand side will also be equal to R. So I will redraw the diagram. This is A, this is point B, okay, and the voltage applied across it, let it be equal to V. There is a resistance above this part which is equal to R1. There is a resistance at the bottom which is equal to R2. The equivalent resistance is equal to R. So basically I can say that the equivalent resistance across AB is equal to R, which is equal to this resistance which is equal to R1, plus the equivalence of both this resistance. Since both this resistance are connected in parallel, it will be equal to R into R2 divided by R plus R2. Okay, it is equal to R into R2 divided by R plus R2. Okay, so let this be equation number 1. We will use this later. Now it is given that after every section the voltage is halved. So I can say the voltage across this section will be equal to V by 2. The total voltage is equal to V. So I can say that the voltage across this section will also be equal to V by 2. Now the voltage across both of them is equal to same. Now the voltage across the first section can be written as V by 2 is equal to certain current, that is the total current, let it be equal to I, into resistance is R1, and the voltage across V2, V by 2, is equal to the total resistance I into the total current I into the total resistance, which is equal to R into R2 divided by R plus R2. Okay, when I equate both of them, I can say that R1 is equal to R into R2 divided by R1 plus R2. When I substitute the values in the first equation, it will be equal to R into R2 divided by, this is not R1, this is just R, okay, divided by R plus R2, okay, this is not R1, plus over here R into R2 divided by R plus R2, which is equal to, if I rearrange this part, it will be equal to R, okay, it will be equal to, over here it will be equal to R is equal to, now since it R1 is same, okay, so what I will do is R is equal to 2 times capital R into R2 divided by R plus R2 okay, over here, which is equal to R and R will get cancelled out. So R plus R2 is equal to 2 times R2. So R is equal to R2. Okay, so the total resistance over here is equal to R2. Okay, let me substitute over here in the first equation. Okay, in the first equation, R1, instead of R I will substitute R2, so it will be equal to R2 square divided by R2 plus R2, which is equal to 2R2. R2 square and this will get cancelled out. R1 by R2 will be equal to 1:2. This will be the ratio of the resistance, which is equal to option number B.